Assalamualaikum warahmatullahi wabarakatuh. We are from Group 4. So today we would like to present our maths project reports. So this is our group member. My name is Amirul Azim Asmi bin Masni. Matrix number AN240033.
Hello, my name is Muhammad Hazi Aiman bin Kamarul Azwan. Number matrix AN240081.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Amirul Ashraf bin Muhammad Azlan. Matric number AN240001.
Hi, my name is Muhammad Izali Fakir bin Kamar Zaman. My matrix number are AN240068.
So we will continue our presentation. So for my part is, I would like to explain about the introduction. So first, the study of differentiation and integration forms the backbone of calculus, providing tools for analyzing and solving various mathematical problems. This includes application in finding maximum and minimum values, as well as working with hyperbolic functions and their inverse. 1.1 Background of the differentiation. Differentiation is the process of finding the derivative of a function which represent the rate at which the function's value change with respect to change in its input. The derivative is a fundamental concept that allows us to analyze the behavior of a function, including their slopes and rates of change. The derivative is defined as f prime x is equals to limit h to 0 f in a bracket x plus h minus fx over h. 1.2 Background of the integration. Basically, integration is the inverse process of differentiation. It involves finding the integral of a function, which can represent areas under curve or accumulate quantities. The fundamental theorem of calculus links differentiation and integration, establishing that they are inverse operation. The integral of a function f(x) over an interval a, b is given by integration of fx dx equals to fb minus fa, where fx is an antiderivative of fx. 1.3 Application of differentiation, maximum and minimum problem. Maximum and minimum problems are essential application of differentiation. To find this value, we are typically first identify critical points. Set the derivative equals to 0 to find point where the function's slope is 0. Second, classify critical points. Use the second derivative test or analyze the first derivative sign around this point to determine if they correspond to local maximum or minimum. And the third, evaluate endpoint for a function defined on closed interval. Evaluate the function at critical points and endpoint to find absolute value. Maximum and minimum problems are essential application of differentiation. To find this value, we first identify critical points by solving f prime x equals to 0. This point can indicate local maximum or minimum. The second derivative test can further classify these points. If f second prime x bigger than 0, the function has a local maximum at x. And if f second prime x is lesser than 0, the function has a local maximum at x. 1.4 Differentiation and integration of hyperbolic function, inverse trigonometric functions, and inverse hyperbolic function. So for the hyperbolic functions such as sin hx, cos hx, and tan hx are analogues of trigonometric functions, but for hyperbolas. Their derivative and integrals are defined as follows. First, the derivative of d over x sin hx equals to cos hx. Second integral cos hx dx equals to sin hx by c. Inverse trigonometric functions. Inverse trigonometric function allows us to find angles from known trigonometric ratio. Their derivative and integral are given by derivative d over x arc sine x equals to 1 over square root of 1 minus x squared. Integral arc tan x dx equals to x arc tan x minus half ln 1 plus x squared plus c. Inverse hyperbolic function. The inverse hyperbolic functions are defined similarly to inverse trigonometric functions. First, derivative. The derivative of inverse trigonometric functions are crucial for solving maximum and minimum problems. So, derivative d over dx arc sine x equals to 1 over the square root of x squared plus 1. Second, integrals. The integrals provide valuable tools for accumulating areas on the curve defined by this function. Integrals arc sine h x dx equals to x arc sine h x minus square root of x squared plus 1 plus c. This comprehensive overview covers the essential aspect of differentiation and integration related to hyperbolic function as well as inverse trigonometric and hyperbolic functions, providing a foundation for solving maximum and minimum problems in calculus. By thoroughly understanding this concept, we can effectively address complex mathematical challenges related to differentiation and integration across various applications. Next, I'll pass to my group member.
2.0 Maximum and minimum problem. Question 1. Determine the point P on the line that is closest to the point 50 and 0. What is the least distance between P and 50, 0? First, we know the line equation is y equals to mx plus c, and then we assume that line equation to y equals to 2x plus 3, and from the equation we get the gradient m1 equals to 2. Then we assume that line perpendicular m1 m2 equals to negative 1. We substitute m1, that is 2, so we got 2 m2 equals to negative 1. Then m2 equals to negative 1 over 2. Question for second line, we use y minus y1 equals to m x minus x1. We substitute the value 50 and 0. We got the answer y equals to negative 1 over 2x plus 25. So we got two equation. Line 1 equals to line 2. We got x equals to 8.8. Next, we substitute the value x to the first equation. We got y equals to 20.6. And then we got point P, 8.8, 20.6. For distance, we use the formula distance x2 minus x1 square plus y2 minus y1 square, then square root. We got the answer for distance 46.06 unit. For question 2, a cylindrical container with a circular base is to hold 64-inch cube. Calculate its dimensions so that the amount surface area of metal required is a minimum when the container is an open can. From this question, we know that volume is 64 inch cube. We know that formula for volume of cylinder is V equals to pi r square h. So we put h in front. We got h equals to 64 over pi r square. Surface area of an open cylinder. The formula is A equals to pi r square plus 2 pi r multiplied by 64 over pi r square. We simplify, we got pi r square plus 128 over pi r square. We differentiate the area, we got 2 pi r minus 128 over r square. We let the differentiation of area equals to 0. We got r equals to 4 over square root of 3 pi equals to 2.03 inch. Next, we substitute r to the equation h. The answer is h equals to 2.03 inch. And then we recheck. We get the same answer is 64 inch cube. For last question, we need to choose one example of a maximum and minimum problem and solve using concept of differentiation. We choose these questions. Find the dimensions of a rectangle that maximizes the area when the perimeter is 100 cm. So the P is 100. We can create an equation P equals to 2x plus 2y. We simplify, we got x plus y equals to 50. Now we find the area of rectangle. A equals to xy. We put the y in front. We got y equals to 50 minus x. Next we substitute y. We got the area 50 minus x squared. Next step is we differentiate the area over x equals to 50 minus 2x. We let the differentiation of area equals to 0. We got the value of x equals to 25. Next, we substitute the x value to the equation y. We got y equals to 25. So the final answer is x equals to 25 and y equals to 25.
Okay, so next question is determine the differentiation of the following function with respect to x. A, fx equal to sin h bracket 1 over x. To solve this, you need to let u 1 over x, so u prime equals to negative 1 over x to the power of 2. So you need to make times it with negative 1 over x to power of 2. So the answer is cos bracket 1 over x bracket over x to the power of 2. Next part is tan h bracket ln x. So the derivative of tan h u bracket is secant h to the power of 2 u bracket times with u prime. So we must let u equals to ln x. So u prime is 1 over x. So secant h to the power of 2 bracket ln x times with 1 over x. So we get secant h to the power of 2 bracket ln x over x. After that, fx equals to sine inverse 3x. The derivative of sin inverse u bracket is 1 over square root 1 minus u to the power of 2 times with u prime. So we must let u equals to 3x, so u prime equals to 3. F prime x equals to 1 over to the power of root 1 minus bracket 3x to the power of 2 times with 3. So the answer is 3 over power of root 1 minus 9x to the power of 2. Next is fx equals to ln x cos inverse x. This is product rule problem where u equals to ln x and v equals to cos inverse x. Our u prime is 1 over x and v prime is negative 1 over power root of 1 minus x to the power of 2. So 1 over x times with cos inverse x plus ln x times with bracket negative 1 over to the power of root 1 over x times power of 2 bracket. So our answer is cos inverse x over x minus ln x over 1 minus x to the power of 2. So next is fx equal to cos h inverse bracket x over 5 bracket. So the derivative of cos h inverse is u is 1 over power root of u power of 2 minus 1 times with u prime. So let u x over 5, so u prime is 1 over 5. F prime x equals to 1 over power root bracket x over 5 to power of 2 minus 1 times with 1 over 5. And then we get 1 over 5 power root of x power of 2 over 25 minus 1. So the final answer is 1 over power root of x power of 2 minus 25. So the last question is fx equals to 1 over tan h inverse x. So we must use quotient rule. So our f prime x is u negative u prime over u2, where u is tan h inverse x. So the derivative of tan h inverse is 1 over 1 minus x to the power of 2, and then we get negative 1 over 1 minus x to the power of 2 over tan h inverse x to the power of 2. So our final answer is negative 1 over bracket 1 minus x to the power of 2 and tan h inverse x to the power of 2. Moving to the next question. Question 5. Determine the integration of the following function with respect to x. The first question, if fx is equal to x squared cosecant h 4x cubed times square. Okay, first of all, let's look at the formula of the derivative. Cotangent h u is cosecant h square u. We shall identify the antiderivative. So first of all, let use 4x cubed as u, and then we differentiate it. We got du is equal to 12x square dx, and then x squared dx is equals to 1 over 12 du. And then substitute it into the integral. On the original integral, we got the x squared
integrate x square cosecant h square 4x cubed dx, and then it will become 1 over 12 integrate cosecant h square u du. And then the integral of cosecant h square u is negative cotangent hu, and then it will become 1 over 12 times negative cotangent hu plus c. And then substitute back u that is 4x cubed into the integral. It will become negative 1 over 12 cotangent 4x cubed plus c. Under B question, we got fx is equal to x secant h x square. On this formula, the derivative of tangent hu is secant h square u, which help identify the antiderivative. So first of all, let's put x as u. So as we look at the formula, we will integrate x secant h square x dx. So this doesn't simply directly simplify into a standard integral. It requires integration by parts. So first of all, we put u as x, and then dv as secant h square x dx, and then we will differentiate it. As du we got dx, and v we got tan hx as we integrate the dv. Then integration by part formula are integrate u dv equals to uv minus integrate v du. Then we put it in the formula, we get x tangent hx minus integrate tangent hx dx. The integral of tangent x is in ln cosecant hx, so it will become x tangent hx minus ln cosecant hx plus c. On to the next question. C. Fx is equal to 3 over 3 plus x squared. This integral matches the standard formula for derivative arctangent x, given by 1 over integrate 1 over 1 plus x squared dx is equal to arctangent x plus c. Factor out the constant, we will get 3. So for example, 3 over 3 plus x squared dx is equal to 3. Integrate 1 over 3, then we factorize the 3, we got 3 times 1 plus x squared over 3 dx. And then we simplify it, and then we will get integrate 1 over 1 plus bracket x over set 3 bracket square dx. And then this will result in answer of set 3 arctangent x over set 3 plus c. On to the next question. D. Fx is equal to negative 3 over set 9 minus x squared. This match the standard formula for the derivative arc sine x, but given by integrate 1 over set a square minus x squared dx is equal to arc sine x over a plus c. Here we got a squared as 9, so a is equal to 3. Then we got integrate negative 3 over set 9 minus x squared dx is equal to negative 3 arc sine x over 3 plus c, as the a is equal to 3. For question E, it is fx is equal to 1 over x times set 1 minus ln x squared. So for the first, let's put ln x as u, and then we will differentiate it as du is equal to 1 over x dx, and then substitute it into the integral. Integrate 1 over x times set 1 minus ln x squared dx will become integrate 1 over set 1 minus u squared du. The integral of 1 over z1 minus u squared is arcsine u. So it will become arcsine ln x plus c as we substitute u into as we substitute ln x into the u. For the final question, fx is equal to negative 3 over x z4 minus x squared. So let's use x squared as u, and then we will differentiate it into du is equal to 2x dx, and then we will use and we got x dx equal to 1 over du. The integral become from integrate negative 3 over x z4 4 minus x squared dx. It will become negative 3 as we factorize it out. Integrate 1 over z4 minus x squared dx. The formula for integrate 1 over z a squared minus x squared dx will equivalent to arcsine x over a, where in our integral it is a is equal to 2. So the final answer for integral fx dx will become negative 3 arcsine x over 2 plus 3 plus c. So in conclusion, this project report serves as an educational resources that outline fundamental concepts in calculus, particularly differentiation and integration, along with their application in solving optimizing problems. Understanding this principle is vital for engineering technology students as they apply mathematically concept to real-world scenario. So this is all of our reference that we use. That is all from us. Thank you.